Assalamualaikum IB to both of my panels, Dr. Afifah binti Yahaya and Professor Wan Ahmad Najmi bin Wan Muhammad. My name is Muhammad Zharif bin Muhammad Samidi, and today I will be presenting my final year project 2, which have been supervised by IR Hazran bin Husain, entitled CFD Analysis of Thermal Comfort in Hospital Operating Rooms with Different Air Ventilation Designs and Operative Temperatures. As an introduction, hospital always need a special care in terms of heating, ventilating and air conditioning system. Referred to dim light chat, patient will heal quicker in regulated environment and vice versa. Besides, there were diligent works conducted to improve the efficiency of the surgical sites. However, infection keeps rising and it is known as surgical site infection. Hence, it is vital to implement high level of ventilation, referring to several significant factors to minimize the infection. Moreover, thermal comfort study obeys to two global guidelines, which are ISO 7730 and ASHRAE 55. Both of these regulations have strong relation in determining the human thermal balance as depicted in the figure, and assisting HVAC designers to build an efficient HVAC system. However, there were complaints by surgeons stated a thermal discomfort in operating room even the room is up to the thermal standard. Hence, it is vital to conduct analysis on this matter to achieve a desired comfort level. There are two objectives in this study, which are to observe the thermal comfort of surgical staff in operating room using PMV and PPD methods, and to perform a simulation in operating room using CFD analytical approach at various operative temperatures and air ventilation arrangements. There are 8 scope of work in this study. This study uses laminar airflow system to measure the comfort condition at surgical staff at different operative temperatures using 16 until 20 degrees Celsius and at 3 various air velocities, which are 0.2, 0.25 and 0.35 meter per second. The boundary conditions are obtained from previous studies and kept at constant value throughout the study. This study uses ANSYS 2020 R2 academic for modeling and simulation process. There are two surgery rooms designs having a different position at their exhaust vent. Design 1 located the exhaust vent at low level, while in design 2 is at high level. Both designs were created identically in terms of dimensions. Other than that, this study uses CBE thermal comfort online tool for PMV and PPD methods. Lastly, this study uses only anesthetist machine, surgical lights, and simplified human blocks. The flow of how to conduct this study will be described in detail under this slide. In methodology of this study, 3 approaches were used and the numerical models were verified with several previous studies. The flow of this study has been summarized in the flowchart given. Under numerical modeling, first is the measurement of surgery room. There are 6 surgical staff as shown in the above figures standing around the patient table and underneath 4 surgical lights and HEPA inlet diffuser. The surgery room models were constructed using ANSYS Geometry 2020 R2 academic. Design 1 has the exhaust vent at low level and high level for design 2. Both designs have identical size dimension, which is 6 times 7 times 3 in meters. Next, these designs consider no instrument except anesthetist machine and surgical lights. Plus, the surgical personnel are fixed at a place and serve as heat source in the operating room. Second is the modeling of human. This numerical model considers simplified human block in order to cut the simulation time, even though this kind of human block tends to overlook the convective heat transmission. However, it is considered appropriate to use because this study focuses on measuring the airflow pattern. Third is the airflow system. This study uses laminar airflow system as referred with several previous studies that using the same flow to analyze comfort condition because it provides low turbulence downward flow and reduce pathogen dispersion. Lastly, the inlet and outlet mechanism. ASHRAE suggested to use inlet which is bigger than the patient table, and this study obeys the suggestion as shown in the dimension between the patient table and diffuser. plus 6 outlets with dimension 0.9 times 0.4 times 0.2 in meter are used in these numerical models. In theoretical calculation, it is vital to acknowledge that this study uses laminar airflow system, which means that the fluid flows smoothly and having a low Reynolds number. Hence, there is no fluctuation occur in these models. There are three conservative laws which are mass, momentum, and energy conservation when using CFD software analysis. The equation for the three conservative laws are shown on the right side of the slide. These three equations can be simplified into transport equation. This transport equation can yield into any of three conservative equations when a valid value is used for the dependent variable. In this slide, the thermal indices gathered all the necessary valid values from previous studies as shown in the table. These values are applied identically to both designs for comfort evaluation. According to H-ray, the temperature used in this study is acceptable because the suggested temperature range is between 16.67 until 26.67 degrees Celsius. Additionally, the uses of air velocity in this study are acceptable because, according to Gavier, air velocity greater than 0.45 meter per second may cause droughts, thermal discomfort, and high infection rates. The recommended relative humidity by Ashray and Balaras are between 20 to 60% and 40 to 60%. Hence, the relative humidity value used in this study is acceptable while maintaining the air changes per hour at 20 in a steady state condition. In the flow of meshing process, the constructed models were imported into ANSYS Fluent with Meshing 2020 R2 Academic. Next, assign a mesh refinement at the inlet and outlet section under Add Local Sizing feature with constant growth rate at 1.2 and target mesh at 11. Noted that there are two meshing processes which are surface mesh and volume mesh. In surface mesh, the minimum and maximum size are assigned at 11 and 150 while keeping other values at constant default. Then, describe the geometry to be consist of fluid regions with no voids. Move further, declare the diffuser and outlet vent as velocity inlet and pressure outlet while assign others boundary as wall. Set the boundary layer at 3 for each wall and keeping other values at constant default. Lastly, assign a minimum and maximum sand length value in volume mesh at 14 and 112 while using polyhexacore subdomains. The simulation is analyzed using ANSYS Fluent 2020 R2 Academic. There are three main parameters for CFD which are setup, solution, and results. This study uses pressure velocity type, absolute velocity formulation, steady time, and downwards gravity force. Tick a laminar and energy model. Next, assign air material under fluid variable for this solid modeling. Then, boundary conditions are assigned constantly for both designs according to the values obtained in thermal indices. Assign the measured various air temperatures and velocities. Select the couple scheme for pressure coupling. For discretization, select least square cell base, second order, and second order upwind for both momentum and energy. Next, select pseudo transient and warp phase gradient correction, which is controlled under default relaxation factor values. Lastly, use hybrid initialization to cut the simulation time and run the analysis under a default pseudo transient setting parameters. These numerical models are verified with few reliable previous studies that conducted in the same field of study experimentally. Firstly, this current study is verified by Liu's work. In Liu's, the authors used same dimension of operating room, diffuser, outlet, and airflow system. Therefore, this current study implements same dimension but with little alteration. This current study uses surgical light, anesthetist machine, and simplified human block to ease the simulation process. There are also two studies from Barako which consider single use of surgical lights, machine, patient table, and airflow system. The authors in Balako's work use different inlet and outlet position, horizontal and vertical laminar airflow, at 25 air changes per hour. There are also 4 other previous studies that use same discretization in CFD software, which is second order upwind and least square cell based. As a result, from these literature readings, this current study constructs a numerical modeling based on the published papers but with few alterations to ease the study. Hence, the present numerical models are verified. Aside from CFD software, the thermal comfort is also being measured using PMV and PPD methods through CBE thermal comfort tool. The interface of the comfort tool is shown in the figure on the right side of the slide. This tool requires input values that being gathered from thermal indices. This tool obeys to 2 global regulations, which are ASHRAE 55 and European standards. Once entered a valid value in the required variables, the PMV and PPD value will be shown above the psychometric chart. Next, the blue region in the chart shows range value that satisfy the global standards. In this study, the result of both numerical modelings are being analysed under 2 forms of distribution, which are velocity and temperature. Under velocity, the results of simulated numerical models are shown in the figure on the right side of the slide, being cut at x-plane. The figures show the effect of using different air velocities and temperatures in operating room for design 1, with a range of value set within 0 until 0.4 meter per second. Hypothetically, the displacement of the air in the operating room get higher when use high velocity. In this slide, the result of simulated models for design 2 are shown in the figure on the right side of the slide, being cut at z-plane. The figures shows a different reaction of air movement in design 2 when using identical of various temperatures and velocities as well as range of measured velocity as design 1. It is observed that the displacement of air distribution in design 2 is higher than design 1. Under temperature distribution, the results of simulated models for design 1 is shown in the figure given, being cut at y-plane. The figures shows the influence of using various temperatures and velocities in temperature distribution. In this result, the main region to be observed is the human block, which represent the surgical staff. The higher the contour displacement, the more uncomfortable the surgical staff will feel. From the result in design 1, it is observed that the surgical staff are more comfortable when using air velocity at 0.35 meter per second. For design 2, the results are shown in the figures given, being cut at y-plane. It is observed that the contour displacement is lesser than design 1, which illustrates that the surgical staff are more comfortable. However, this result from CFD analysis need to be related with the PMV and PPD data obtained from CBE Thermal Comfort online tool in order to achieve desired comfort conditions. Under PMV results, it is observed that nurse anaesthetist has the highest PMV value. Surgeon and scrub surgical tech have a lowest PMV value throughout 5 measured temperatures and 3 different air velocities. The graph shows linearly increasing as measured temperature increase. In this study, it is recommended to have a PMV value between -1 until +1 as studied by Zwolinska to achieve comfort level. It is observed that most of the surgical staff are experiencing near cool sensation due to the metabolic rate and clothing insulation. Nurse anaesthetist has the lowest metabolic rate and insulation because they spend most of the time sitting in front of anaesthetist machine. Hence, the heat from the machine and light can balance the coolness they experience. For PPD results, it has strong relation to PMV value where it predicts the thermal dissatisfaction of surgical staff. The recommended value of PPD must be below than 20% to obtain optimal comfort. Relation to PMV data, nurse anaesthetist has the highest dissatisfaction percentage in 5 measured temperatures and 3 different air velocities. The PPD graph shows linearly decreasing approaching 0. It is impossible to get 0% of thermal dissatisfaction as the relation between PMV and PPD theoretically not intercept at 0 value. Hence, most of surgical workers are dissatisfied when using temperature below 19 degree. Therefore, the appropriate design of surgery room must be implemented as Design 2 having condition above 19 degrees Celsius at 0.2 or 0.35 meter per second. Both designs are being compared in velocity distribution under same temperature and velocity, which are 19 degrees Celsius and 0.2 meter per second. It is found that Design 2 has a minimal air circulation compared to Design 1. It is assumed that the air circulation in Design 2 is exhausted easier as position of exhaust vent is at high level when the exact region of air circulation occurs. It is found that when air circulation is minimal, the risk of infection is decreased. Thus, it will provide a safe surgery room for surgical operation. Under temperature distribution, the simulated models are being compared under same temperature at 19 degrees Celsius and velocity at 0.25 meter per second. It is found that the contour displacement in Design 2 is low compared to Design 1. It is vital to understand that the greater the contour displacement, the more uncomfortable the individuals will feel. Hence, Design 2 provide a better thermal surrounding for surgical staff and satisfy the suggested temperature range between 20 until 22 degrees Celsius. To put an end to this presentation, it is agreeable that thermal comfort is affected by few significant factors such as environmental, individual, instrument and devices, position of air distribution, airflow system and many more. It is found that the study of thermal comfort is really subjective as these factors are varies according to its necessities, and this study can be improved by conducting an on-site measurement. That's all from me. Thank you so much for your time. Stay safe and Assalamualaikum.